So I work in the CTO office and mostly on things like AI, but also nowadays mostly on the research side. And I want to talk here today a little bit about the things which are not really paid that much attention to when it comes to all this machine learning stuff and so on. So when people are talking about machine learning nowadays, and which I get excited about, is things like image recognition. So things like this are very popular. So especially recognizing cat videos is one of the most important things you have to do on the internet anyway. So, and therefore, we are toying most of the time with problems which really don't have that many consequences, or at least really important consequences. So image captioning, so describing what you see on an image and so on, is a nice little thing. So it's something which is very time-consuming to do if you don't have a computer actually doing this for you and so on. But what are the consequences of getting this wrong, of not getting it? What is the consequence of if one of your favorite social networks is recommending someone who is not really compatible with you as your next best friend and so on? So no one cares about these kind of things, really, so about equality, which makes it really an attractive target for all these machine learning researchers out there because they don't have to face the consequences of them getting their models wrong. This is the background, basically, among, can we have the normal microphones? This is the background, basically, for, where are we, here, for things which I'm really interested in. So now it says not really I'm only, because at Red Hat, we are really an infrastructure company most of the time. So we're not really building end-to-end solutions in these things. We're helping people coming up with solutions and so on. We also, the thing which is new about the machine learning aspect now, so we have all these additional tools out there we could potentially help people using, and we can actually solve problems which we couldn't do before, but we don't necessarily have to do this. We just need to get to the point that we can actually deliver this from our side. But we also need everyone out there to actually rethink how we can actually use these kind of tools nowadays in situations where we traditionally haven't been able to, or haven't even thought about using them. So we have all kinds of existing problems which pretty much every deployment and so on is out there. And for those of you who are actually programmers there, you will recognize these kind of things. So as a programmer, you get a specification, or you have the idea what a program is supposed to do. And you're programming along this. But most of the time, the program, ideally, is not really useful in one single specific instance and so on. You write it so that it is usable in more than one situations. And what this means can actually vary. So you can execute it on different types of machines. You can use it for different types of projects and so on. And the kind of way you're actually doing this is, of course, you're writing a more generic algorithm. But most of the time, there is somewhere some form of assumption which you have to make for the specific instance, the specific compilation of the program, about how this is actually being done, how the actual implementation has to happen. And this is where a problem really comes in, where forever, entire programming history out there has always been that the programmers simply make assumptions. And they are adding configurations, options in there where they basically push the ball down the street and say, well, you, the user of the program, will have to make the decision for me. And they are generating their code to be able to handle all kinds of situations based on the configuration variables. But neither of these kind of things are actually pretty good solutions in the first place. The same is true also for system administrators. So you can think them as consumers of the programs which the developers have been writing, but they themselves are actually also writing all kinds of code to administrate large networks and so on. You cannot handhold entire single machines anymore if you as a single individual are handling 100,000 machines, but you still have to be able to, for instance, monitor them, or you have to bring them up in some way or form. And we heard already about things like placement of compute jobs and so on. And these kind of things are normally done using some form of scripting, and most organizations, at least the ones I've seen, all of these kind of tooling and so on is static. So things like monitoring a network system and so on for some form of faults or overloading and things like that, you will see that the system administrating infrastructure there pretty much then says, well, if it's too high by this level, well, then flag it. But what constitutes too high in one situation might not be too high in another situation, and over time things can change as well. So that's another problem by itself. So graphically speaking, so if you have a timeline, you measure something like this. So is this something which is actually wrong or not? Well, if you have static bounds of some sorts, and I've seen this being implemented many, many times, by simply saying for instance, if this would be the CPU load or something like that, if the load is above that or below that, something is wrong. These are static things, but this doesn't really work in practice. So what if, for instance, over time, the baseline is changing, which most of the time it actually is. So in these kind of situations, the scripts, after a certain amount of time has passed, will constantly alert. And then the person who is actually looking at the alerts will say, yeah, I know it fails, so just ignore it. Believe me, I've seen this many, many times, even in places where it's actually costing billions of dollars to actually miss a mistake. So the other thing is seasonality. So for instance, you have network traffic and so on, where you expect that during the day you have, during the different periods of the day, you have different amounts of traffic which is coming in. Or you have long times periods, for instance, if you have an e-commerce site and so on, just before the holidays, you might have a spike, the rest it's not. So how do you distinguish these kind of things? And you don't want to hard code this either, as I said before. So you don't want to say, yeah, I know the two seasons which can happen, the 24-hour season and there's the 365-day season and so on, and hard code this. But there might be other ones. You don't actually know what it is. So any kind of static information like that is a bad idea in any kind of program. So what instead could we do? So best would be if the developers are not actually hard coding any kind of thing. Whenever there is a place in your code, it should in some way or form be done by a form of a model. So you basically say, here is a parameter and so on. I don't know what it is. Well, for now, put in something which is reasonable, but make sure that this can be adjusted to the appropriate situation. And this also means that the adjustment period and so on, ideally, you should be able to readjust it every once in a while. Ideally, it's a dynamic thing even. So these kind of things are possible. We have this. So we have, for instance, in the machine learning world, we had something called online learning, where basically while the model is running, we can we can adjust the model with when new data comes in. So perhaps you can do that. But this also means that the data should not just be that the same parameters, the same values are actually used by everyone at the same point in time. In different deployments, it can and should be different. So this by itself makes it possible to adjust to different kinds of deployments. And for instance, a 24-hour cycle and so on, if you go by a clock which is, as in the Unix world, is usual that you say it's all based on Greenwich Mean Time. So what the 24-hour clock cycle means for a different location, is different. So you have different offsets, and that can be handled automatically if you allow completely independent models for the different deployments. But the main benefit of this would really be that the person who is actually deploying the applications and so on doesn't have to know about all the different configuration parameters. So for those who have been living with the Unix system specifically, but probably on the Windows side, it's probably exactly the same. You have seen that many of the programs which are highly specialized, let's say something like an Apache server, they have hundreds, if not thousands of configuration variables which you can set. Who is here really able to say that they have even touched 10% of those? It's far too complicated to get into this, especially also if you're looking at all the interactions between different parameters. So by not actually exposing any of that to the user in the first place would actually allow us to go in the direction that we can have a much easier way of deploying the applications, because they would be learning automatically. So, and the last thing which I have here on the side is basically saying that this also means that the deployment will also not using any really bad settings. This could also be caught by the models so that we actually never actually hitting this. But one of the other things out of this, if we would be implementing these kind of things, is first of all that the implementations can be quite sophisticated, because which would not really be necessarily possible before, because the kind of nuanced configuration which is necessary to have a really dedicated and efficient implementation, tweaking this all by hand is pretty much impossible, but with a model potentially we can do. And the last thing there to add as well, and this is quite an important thing, but many people haven't really realized this, for some problems, actually basing the configurations and the settings on what a human thinks is actually a bad thing, because regardless of what you think, really, humans always have some form of bias. They're making some form of assumptions of how things should be working, and they will be reflected in the way they're setting configurations, etc. And these kind of things are oftentimes very bad. So intuitions are good as starting points, but they should not be the ultimate thing. So what I'm really suggesting here, well, it's not just me, so what has been suggested for a long time is really that, well, why don't we get rid of all of these kind of things and instead have statistical learning algorithms there which help us to determine things. And this is not something, well, of course, it's not new. We are using this. I'm just suggesting that we are applying all these techniques which we have learned about now in the last, let's say, 20 years now, ever since the revival of statistical learning, and apply them to situations which are much closer to our hearts, so in the Red Hat side and so on, from the system software side, and getting rid of many of the sources of errors which potentially can actually ruin our days. So when you're thinking about how an application normally looks like and so on, the ecosystem which I'm proposing here is something like that. Most of this is already there, so most of this is already present. So the only new things are those which are still here visible without the shading. So instead of the application just running, let the application spit out additional information which is not for the human consumption. The application, for instance, would know things like how long are the queues of my requests, or things like that, or some other form of metrics. Just make sure that whenever you think as a developer that there's something, oh yeah, this might be interesting to know in future to see whether my application runs really well, just make sure we can export this in some way or form. We already have possibilities with the system software which we have available to measure in general, using in general terms, the performance of an application. So we have performance measurement tools and so on. We are just not using them unconditionally. We're only using them nowadays for performance monitoring and so on, and when we're doing profiling for optimization. But what if we just would run many of these kind of things constantly all the time? So we have data which is coming directly from the application. We have data which can be collected automatically from the system running the application and so on. Use this kind of thing as model inputs, which we have in some way or form pre-trained, but this model can be online, so it can adjust itself to different situations. And as the output of models, we can have both settings for the operating system to run the specific process, and also settings for the program itself to adjust it. So there are ways how we can adjust the running process by itself, but we also specifically can potentially rewrite what amounts to the configuration file of a process so that next time we are running it, getting this. So Oren Krieger, you heard about him in the first talk when Mike talked about the UMass stack. So Oren and I have been talking for a long time about the problem that most of the time when we are running an application today, on a normal system, whereas the operating system is every single time surprised to see the application. Oh, I've never seen you before. So we are really have to get to the point that we know something about the application because we have run it before, and we keep this information around so that the next time we run it, we are actually running it better than before. So all we have to do is collect the appropriate information from the system, which in many cases is quite simple. So, and especially, the information doesn't have to be human consumable. So you can have some obscure measure out of there. And many of the statistical methods which we have out there can even filter out all kinds of signals which are unimportant. So most of the time, it's really the first important thing is to get all the data out of the program, out of the system in the first place, so that we actually can run models. We can, if it's too much, well, that's much less of an issue is if we have too little information available there. So we can always throw things out. And the things like, as I said, execution performance using performance measurement counters and other counters in the system we already can have. We are using them to some extent. There are projects like PCP, Performance Copilot, and so on, which can monitor the system by itself, but we are not using them to actually retain information about a specific process or application of a specific process. We just have to do this as an additional step there. So, and then we're developing a model on this. So I'm not suggesting, and this is not so that you throw just any kind of learning mechanism on it. So this might work, and so on. Many people are simply of the opinion that neural networks are a generalized learning algorithm, which is, in my opinion, wrong. But we know something about the application, specifically if the model we are using could also be, in partly at least, be developed by the developers, initial developers of the application. So they know something about the application, and we can potentially embed this in the model itself. So the model itself, so there are all kinds of techniques to make them, to create models, to filter out unimportant information. So these kind of things is there. It's not a solved problem, but it's something which we understand to some extent. And if you're taking the help of some data scientists, well, this is something which can easily be done. We can easily build infrastructure to do retraining on all kinds of data, on accumulated data. But as I said, we could also do online data. And these kind of things are easy enough to do. So that is something which we have been doing in other situations. We're just not applying it to things like system engineering. So a couple of examples in there. So there's a project called buffer bloat. You have seen that. And it's just a manifestation of a problem that in the network stack, to get higher performance and throughput and so on, all kinds of buffers go larger and larger and larger. So Dave is not nodding yet, but I think he's very much aware of the problem and so on. We have been trying to battle this kind of thing in the kernel in form of configurations. But this is not the right thing of doing this, because in some situations, perhaps the high values for the size of the buffers is exactly what you need. What if you can do this, perhaps even on an application basis, based on the situation which the application with the feedback of the application says, well, this is the correct buffer size which I need here. So we can build up models for this. We can also monitor the system by itself and look at patterns by itself. So we can, and again, for the entire system itself, so we can see how the different processes are interacting with each other, but we don't have to describe how this is, because it's not really that much of an issue for have high-dimensional inputs for models and so on. We are talking today about models which we are training, which have hundreds of thousands of inputs and so on. So we can easily deal with that. So what if we just have a system which you're assigning appropriate markers to all the different processes and the individual measurements we're doing, doesn't just running something and recognizing when something is bad, when something is good, and so on, and then have the system automatically tweak it and learn what does something good, what does something bad. The only thing which we need is some form of cost function. In the end, which says this is better than the other one, this is worse than the other configuration. And this can be going on in the background all the time. So, but we can also go to a level which has not really been the focus of much of the attention of the machine learning world, is where we can actually work with the developers themselves. So, for instance, if anyone is actually writes source code and so on, you would really like to have someone who's doing the mundane tasks for you. So, who's suggesting what kind of function to call, what correcting the way you have been writing it, or that you would want to use abbreviations of the way you're usually writing things, and the system is recognizing this and perhaps expanding it into code which actually works in these kind of things. This kind of thing can be integrated into the editing environments, in the editors. It can be integrated into the compilers. It can be anywhere there. So these are places where we can also use machine learning techniques where we are currently not using them at all. So the compiler by itself is also something which has all kinds of heuristics. So if you're using GCC --help equals params. So that's an option which shows you all the parameters which can be tweaked in GCC at the command line. We have 223 variables there. So anyone here ever changed one of them? Probably no one. Yeah, okay. 2 people here. And they probably only changed a couple of them. So these are things which can influence the way their code is finally behaving, because they're changing things like how much do you do inlining and so on. This is something which depends on your project, not on the compiler version. So what if we can actually remove these and learn from the code looks like this? My goal is to have the highest performance or have the smallest binary size and have different parameters based on that, instead of having a once selected heuristic value which comes from the compiler developers. So, and from the performance analysis side, so that's something which I'm very much interested in, is this is a very labor-intensive process in the moment. So you have to do all kinds of have to know all kinds of things about your CPU. You have to know what can be measured and so on, and then have to do a stepwise process to actually isolate which at what time in the lifetime of your process is actually the bottleneck there, what can be improved, etc. What if you can run this through a model? It can recognize certain aspects of your program run and so on, and to actually suggest things, or even at some point rewrite or recompile your code so that it actually performs better. That's not really anything different from recognizing whether your image is a cat or not. It's just data which comes out in a form. We just have to make sure that we are presenting the data in a form which can be consumed by a machine learning model. So why I'm here specifically is I want to get people interested in this. So most of the machine learning groups anywhere at any university is really interested in these the same projects which the main researchers are interested in, as I said, image recognition, natural language processing, and so on. But what if you have interest mainly in system engineering and so on, you want to have a PhD in this area and so on, but you're also interested in machine learning, so just think about the intersection there. So that's the part which we are particularly interested in. So talk to me either directly or go through you and his organization and talk to them about this is something where, from our point of view, there would be a huge overlap in interest. And there are many, many different places, and I just listed a couple of them here, where we can have potential collaborations there. All right, any kind of questions?
Any questions?
Hey, so I was wondering, sorry, is there any native top-level language direct support of all of these tools that for developers he can develop their own thing with on the background, these profiling and learning tools being enabled? For example, if there are some directives in Java, in libraries like that, that they can focus only on OOP, and as the result of the application will not be only output, but whole this framework working together?
Well, I don't think there's anything in the moment which does this all for you. So this would be part of perhaps the work which can be done to create such an entirely encompassing framework to do this kind of work. So in the moment, yeah, no, there is nothing like this.
Because it strikes me like completely new philosophy how to develop applications. Because, for example, as quality engineers, if we had something like this directly in application without enabling some external debugging tools, external debugging symbols and these kind of things, without big performance impact, we could easily debug everything and we could figure out the black box behavior. So I'm wondering how this is demanding on developers if we want to enable it from scratch to any application.
Well, that's a different question by itself. So how do we get developers to actually accept that these kind of model inputs and so on? So that can actually be pretty simple. So it doesn't have to change that much from the way we are doing it right now. So it can be a variable, a global variable somewhere in your program, which is determining thing. The only thing is that the assumption cannot be made that the variable stays the same over the lifetime of the process. So that's the only thing which has to be put into the minds of the developers. And if we have that, then we already have tooling out there. So you can do it by scripting GDB in the most simple case to say, I have this process here, change the value of the variable so-and-so to this value. That can be scripted today, so I don't say that this is the ideal way. So we have other ways to do this much more efficiently. But this is, for instance, the way you can once you learn something, I want to have a train the system to do something and adjust the values. So this exists. So don't ask me about what you do in Java. No one who's interested in performance should use Java. So who cares about that crap? So, but any kind of other program, you already can do this. So the point of the ecosystem to get all these kind of things together, that's an open problem, but it's not something unsolved. So we, specifically Red Hat side, we have lots of people in the tools group who are working on all the individual pieces. So we have things like system type and so on to get data out of the system, but also potentially set variables and so on. We have a set tooling which is behind GDB and so on, which can set things. We have in the kernel all kinds of infrastructure so that you can do these kind of things securely in a remote process and so on. That's all there. We just have to have potentially some little infrastructure around this to make it much easier for a developer to actually integrate this. But this is not really difficult at all. So the main thing is to get to the point that we actually have the data coming out of the process and setting up the modeling. So influencing then from the model the running process or configuration file writing, and that's an easy part.
Thank you.
All right, Stephen.
So we're actually looking at this for a number of subsystems. And one of the things I'm struggling with is understanding, first, do no harm. So, hypothetical situation, my service has been running for weeks with no problems. I suddenly see a big load spike. I try to adapt to make sure things are running more efficiently. I guess wrongly. I expand the amount of memory my service is running. It hits a hard limit, kills the process. And my monthly payroll, which is a batch job that was running that I wasn't anticipating, fails for the month. So there's really a couple of things come to mind. First of all, what do I do in development to pre-process the model to have confidence that I'm making the correct adjustments when I go to production? And how do I minimize the production risk by saying, should I be doing advisory about what you might want to tweak and let the operator figure out when's a safe time to make those choices? What's the experience for how do I make sure I'm adding value and minimizing risk when I've got things changing behind the scenes in unpredictable manner?
Yeah. Well, one of the things is that, as what I mentioned in the beginning, so the machine learning developers make themselves a really easy life by not having life-critical decisions being made in the moment. So they have not really thought about these kind of things in most cases. So so in many situations and so on, you can, in the model creation, you can build this in. So you can have cost functions, which, for instance, say things like, if the amount of memory you're trying to give the process is growing, so you have an additional cost associated with that, which means that if you give it too much, the solution will never be actually selected in the first place. So things like that you can build into the model by itself. But the rest is similar to what we would be doing today in configuration file parsing, perhaps there. So we have to do something similar to that going forward if you want to be 100% sure. But in general, yeah, so there is not really anything which already exists out there to mitigate these kind of problems, except perhaps the case that we can do it with a much higher frequency if necessary. So you don't have to wait 10 minutes for the server to spike. You can potentially say, I have my model, so I have an expectation of how the performance curve, perhaps after I tweak something, is behaving. If it's diverging from that, I will recompute the model very, very quickly and adjust it again. So in this situation, it might actually be better than what a human can achieve.